So last class we discussed together the single phase induction motor problem. Firstly, we discussed, let me just give a brief about the previous class. Firstly, we discussed the introduction to different single phase motors, and we discussed the different types as induction, synchronous, and other type of special machine like universal. Okay, and we said the single phase induction motor is mostly used due to its simplicity and a lower cost compared to other motors, especially in domestic loads, because in domestic loads we don't care a lot about the efficiency, okay, and we care about the cost. For that, we use in most of domestic loads we use single phase induction motors. Also, we discussed the construction, and we said that the single phase induction motor has two mechanical parts, which are stator and rotor. And in terms of windings, we have a stator winding, like any stationary, like any winding in a stationary part, okay? But this is now one phase only. And the rotor is made of squirrel cage like the three-phase one. And in terms of mechanical parts, these are the mechanical construction. This is our rotor shape. It's nothing but squirrel cage type. This is our squirrel cage type rotor. And for the stator core, it's made of lamination of sheet steel and collected together to make stator core. And inside the inner surface, we have some slots and we insert the windings. And we said that we have a problem in starting in this type of motors. For that, we have two different types of windings. And as you can see here, the different types of windings have a phase shift of 90 degrees. And we'll discuss it, inshallah, in this class. Also, we discussed the problem of double rotating field theory. If we supply any single phase machine, with a single phase AC supply, we will have a flux like that. Flux of two components, okay? One component is called forward flux in angle omega t minus theta, and another is called backward flux as a function of angle omega t plus theta. If we compare the two components of fluxes, we can find that at a certain instance, we can find both of fluxes are in phase. So this means that the peak of flux will be, or the summation of flux will be twice of each one, because both of them has the same magnitude. As you can see here, the magnitude for each flux is Ni maximum over 2. So this is the peak value of each flux, and only the difference is in the phase and rotation. So this is at one instant, okay? So it will be summated together. When the vectors start moving, one in direction of plus theta and one in direction of minus theta, so the resultant field will be the summation of the two vectors. So the resultant will be, and for any vector summation, it will be like that. So this will be the vector summation, which is this one, resultant vector. طبعا if the vector rotates to be flat together like that, which means one is in the opposite direction of the other, the resultant flux will be 0. And so on, it will continue moving in the other direction, so it will be repeated again and so on. So this is the way of flux rotation. So finally, we will have forward flux in this direction and backward flux in the other direction. And the summation of these two fluxes will be the resultant flux. As you can see, this is the component of torque. This one is the component of torque due to forward flux, and this component of torque is due to backward flux. At the instant of 0 speed, you can find that both of components are equal in magnitude and opposite in direction, which means the resultant torque at that point equals 0, which represents this point, So this point appears at starting. For that, we have a problem in starting the machine. Fine. We said in previous class we can make a solution to do that. Who can remind me, مين يفكرنا شباب يعني what is the solution يعني just يعني ايه not electrical solution. We said that we can make يعني one solution to start operating the machine.
We start to spin the rotor.
By spinning the rotor, exactly. So if we just spin the rotor, what do you think? If we spin the rotor in that direction here, the motor will rotate in which direction now? In the positive or reverse direction?
Positive.
In the positive direction. So if we add يا شباب يعني spinning the motor in one direction means we added external component for torque, for instance, in that direction. So this means the summation of torque due to the electrical torque and the torque by spin itself will be higher a bit, maybe like that, up till just start moving the motor. And after the motor moves, it will continue on the other characteristic and moving in forward direction. And if you have a certain load, it will intersect the characteristic of the machine at one point, which is the operating point, and will continue moving in that direction. However, if you make the spin in the opposite direction, the motor will start moving in the opposite direction. And we said sometimes يعني some people are using such way to start the motor. طبعا it's not automated way, but يعني it's sufficient to start the motor, especially شباب in workshops. يعني workshops sometimes they just use a spin by hand to start motoring, to start operation of the motor. And also we gave another example like in boats شباب, like in boat also they make like a wire to make a spin for the motor in order to start the motor operation. Okay. However, the automated way يعني there are many automated way inshallah. We will discuss it in our class today. So what are the starting idea now? Let's discuss it inshallah in details. The simplest method of starting single phase induction motor is to provide an auxiliary winding. So if we added auxiliary winding, what will happen? What do you expect if you have another winding in the machine? What do you think, Shabir?
The electrical develop will decrease.
It may cause a flux, okay, which makes difference in degrees between the two component of fluxes in the starting point. So this is now the idea. Great, thank you, Shabir. So if we added auxiliary winding, Shabir, on the stator in addition to the main winding and start the motor as two-phase machine. طبعا I know you do not know or discuss before we did not discuss the two-phase machines. However, there is a motor called two-phase induction motor. Two-phase induction motor. Two-phase induction motor is nothing but two windings in stator with a phase shift of 90 degrees, and we control the voltage at the two windings by means of something called imbalance ratio. Imbalance ratio. By controlling this imbalance ratio, we can control this motor. And by the way, this type of motor is considered also as special type of motors, and it has another name which is AC servo motor. So AC servo motor is nothing but two-phase induction motor. Okay, but يعني طبعا according to the time limitation in our course, we cannot discuss this type of machine. But it's very simple and has a well-known mathematical model, and it's very easy, and you can read it and understand the concept of two-phase induction. So by adding another winding like two-phase, okay, so we will have now two windings in stator. One is called auxiliary winding, and the other one is called main winding. طب why we call it like that? In two-phase induction motor, two windings and have currents. However, here it's different a bit. طبعا in two-phase induction motor, we supply the machine from two different sources, and the phase shift between each source is 90 degrees. However, in single phase, we supply the machine from the same source. It's only single phase. So by making one winding يا شباب as the main winding with the certain impedance which will carry the machine current, and making another small cross-section winding just to create a flux at starting, and the current that will move in this winding will be small, it's not high current. And this winding يا شباب can make a phase shift in order to make just starting technology. Now, how we can proceed operating this winding if it cannot take high current? طبعا we don't need this winding after starting, so we can easily remove the winding from the operation. How we can do that? We can use a mechanical switch called centrifugal switch, and this centrifugal switch شباب can just disconnect it mechanically if the speed reaches to a certain value. Okay شباب, so this is the idea now. We will have two windings. One of them will create a component for flux at starting, and after reaching to a certain point of speed, we can disconnect this winding. So this is a discussion here. Two windings are placed in the stator with their axes displaced 90 degrees. This is what we could see in the mechanical structure here. As we said, we have one winding as main. Okay, assume that this color is for main winding. Okay, and the other color here is for the auxiliary winding. So there is a mechanical phase shift of 90 degrees between the two coils. The impedances of the two circuits are such that the currents in the main and auxiliary windings are phase shifted from each other. This is the concept. If you have a phase shift in the beginning, this is going to make a difference between positive and negative flux, or sorry, forward and backward flux, which is equivalent يا شباب to unbalanced two-phase. Unbalanced because in two-phase, as we discussed, it's controlled by means something called imbalance ratio, because we have to make imbalance in order to control the speed of two-phase induction motor. We are not going to go in deep in discussing two-phase induction motor. However, this is the concept. So just the idea is to make phase shift. To make phase shift, this needs special design of winding. As we said, the auxiliary winding has to be made from cross-section wires with cross-section different to the main winding in order to have different characteristics. Instead of have R and L with the coil with higher inductance, we can make it with higher resistance. So in this case, the phase shift between the impedance will be high enough in order to make flux to start moving the machine. So this is the idea now. So the two windings can properly designed to make the motor behave as balanced two-phase motor. In the running condition, a single-phase induction motor can develop a torque with only the main winding. Therefore, as the motor speeds up, the auxiliary winding can be taken out. This is as we discussed, شباب. We will remove the windings from the operation. But when we can remove it, in most of motors, this is done by connecting a centrifugal switch. This is mechanical switch. Depends on the speed, يا شباب. In the auxiliary circuit, at about 70% of the synchronous speed, this switch will be disconnected. So it will be disconnected automatically at 75% of the speed. Let's see together. What will be the effect if we include the two windings in one motor? We will discuss this يا شباب by means of an example. Here it's stated in this example. The currents in the main and the auxiliary windings are as IA equals square root of 2IA cosine omega t plus theta A. This is A subscribe the auxiliary winding. So this is for auxiliary winding. And Im, which is main, square root of 2 Im cosine omega t. So we have now two windings currents with a phase shift of theta A as general now. And later we can see what is the effect of changing the angle theta A. The effective numbers of turns for the main and auxiliary windings are Nm and Na. So each coil يا شباب has its own number of turns, Nm and Na. The windings are placed in quadrature, which means there is a shift in mechanical installation of these windings within the stator by 90 degrees. This is the rule of making auxiliary winding in single-phase induction. What is needed here? Obtain expressions for the stator rotating MMF waves. Now, we expect to have forward and backward MMF. So what will be the relation for each one? Yani in case of single phase, we could single winding, we could obtain a relation of N I maximum over 2 cosine omega t minus theta and omega t plus theta. This is for forward and backward flux. Now, what will be the relation if we applied two windings within the machine? So let's see together, شباب, what will be the effective value of MMF now. Firstly, the stator MMF along a position defined by angle theta, where the theta is 0 شباب for the axis of the main winding. So we can say the total MMF, F of theta and T, equals F main of theta and T plus F auxiliary, because we have two windings now. طبعا, you know, the MMF is nothing but N multiplied by I. So we can say now N main multiplied by I main, which is I maximum cosine theta. Sorry, I main cosine theta. So this is now MMF as a function of N and I multiplied by cosine theta, because we have Fm as a function of theta and T. So current is a function of T and the MMF is a function of theta. The same is also for the MMF for the auxiliary winding, NIA, NAIA, cosine theta plus 90 degrees. Why plus 90 degrees? Because we said it's shifted by 90 degrees here, okay, placed in quadrature. Then substitute with the value of Im and Ia in the relation. So the relation will be like that: N main multiplied by square root of 2 I main maximum cosine omega t. So this is the current of Im. Sorry, Im here root mean square, not maximum, because square root of 2 multiplied by I RMS, which is the maximum current. Okay, as it's given here. Okay, and square root of 2 multiplied by I RMS. M here is subscription for main, not for maximum. Okay, so here this is I RMS value. So N main multiplied by square root of 2 I main RMS cosine omega t cosine theta. This is now the MMF for forward flux, and for the backward will be NA auxiliary multiplied by square root of 2 IA, which is the RMS value of auxiliary current, cosine omega t plus theta. This is the function of current multiplied by cosine theta plus 90. Now you have this function. You can start modifying this function. We have here cosine, and here cosine omega t plus theta, cosine theta plus 90. And you can follow the steps here in the derivation until reaching to the final form of our relation. The final form in our relation, شباب, will be like that. F of theta and T. By the way, it's not important to drive the equation. It's just to understand what is the result of this theory if we apply the two windings. So the function f of theta and t equals square root of 2 nmim cosine omega t cosine theta. And we have another part as a function of auxiliary winding multiplied by cosine theta a cosine omega t sine theta, and another third part for the auxiliary winding as a function of sine theta a multiplied by sine omega t sine theta. Now we can use these trigonometric function equations in order to modify a bit the relations, and we can finally reach to these two parts of relationship. One is function of cosine omega t plus theta, sine omega t plus theta, and another is a function of cosine omega t minus theta and sine omega t minus theta. What is the aim now? Why we need to get it like that? Because we have one component for forward flux and another for backward flux. Omega t minus theta representing the forward flux. So this part now of the equation representing F forward. طبعا which one is for main and which one is for auxiliary? طبعا the part which is multiplied by n main I main is for main, and the part which is multiplied by NA IA is for auxiliary. However, now we classify the MMF to be as a function of forward and backward, not main and auxiliary. Okay, because now, or finally, the machine will rotate as a function of forward and backward. We don't care now about which is the component of main winding and which one is a component of auxiliary winding. So, as you can see now, we have two parts. One in backward flux, so this component in backward, and this component is for forward flux. طيب يعني as you can see now, it's long mathematical expression. يعني we need to understand how we can make a difference in order to start the operation. Actually, شباب, if we control the terms NMIM and NAIA and control the terms theta as we discussed here, if we kept theta A as 90 degrees, okay, if we kept theta A at 90 degrees and controlling NAIA and NMIM terms by controlling number of terms and current for each winding, we can contribute to have a rotating flux in the beginning. Let's see together, شباب, if we substitute at theta equal 90 degrees. طبعا sine 90 equals 1, صح? So this term will be unity. Here, cosine 90 equals 0, so this term will be removed at 90 degrees. Now, here, this is sine theta, so this term will be unity. And this term is a function of cosine theta, so this term also will be removed. So finally, we will have, if we have 90 degrees, we will have only these two parts. 90 degrees, it means theta A equal 90 degrees. Again, what is theta A? Let's return back to the definition here. We said that theta A here, which is the angle of the difference electricity or supply of the two currents, the phase shift between the two currents, which is coming mainly from the, we can call it as the ratio between active and reactive, or resistance and the inductance of the auxiliary winding. Okay. So now, شباب, as you can see here, if we control NM and IM and NA and IA to be equal terms, so if we make the number of terms for auxiliary winding higher than the number of terms of main windings by the ratio to keep NMIM equals NAIA, so in this case we can remove this part from the equation as well, and the remainder part will be NMIM NAIA multiplied by cosine omega t minus theta. Now يا شباب, if we have the function like that, so if we apply the condition NMIM equals NAIA and keep theta A designed to have 90 degrees, which is the difference now between IM and IA, so you will have a resultant flux square root of 2 multiplied by NMIM. طبعا why NMIM? Why not NAIA? طبعا we said both of them are equal. So when you multiply or add them together, it will be multiplied by 2. Okay, so it's nothing but the same now. So we can say now يا شباب, 2 over square root of 2, so it will be square root of 2 multiplied by n maximum, n main, I main, cosine omega t minus theta. Now, if this component of flux يا شباب, or MMF, considered as rotating flux or not? شباب, is it now rotating flux or not?
Yes.
It's rotating because it's sine or cosine. تمام? So comparing this with the double rotating field theory, what we have here, we could have, at a certain condition, we could have a component for flux. And in this component of flux, we can have a torque for the machine in the forward direction, because it's in the angle of forward direction, as you can see, omega t minus theta. And this can now make starting in that direction. So this is شباب, or this theory, or this way, is the method used to make starting automated way without any spin for the motor. Okay, so this is the automated solution. But it depends on some conditions, as we said. It depends on the design of the auxiliary windings to have a phase shift of 90 degrees, and also to have NMIM equals NAIA. Right, the question now, if we change a bit the angle, it will have a component of flux in forward higher than backward. Okay, شباب? So it's not a condition to be exactly the same, but we can control this ratio. We can control this ratio in order to have higher component in the forward direction. And if you have higher component in the forward direction, this means the resultant flux will be at starting will be a positive value, not zero value. And this is sufficient to start our motor. Right. Let's see together the different configuration now. The first configuration, we know this is now the main winding. This is our rotor. And this is here the auxiliary winding. And this is a switch that, the mechanical switch that will be disconnected at a speed of 70% of, or 75% of the synchronous speed. So for synchronous speed, you can easily calculate the synchronous speed as a function of frequency and number of poles. So based on that, at 3/4 of the value of synchronous speed, this switch will be mechanically disconnected. Type. Before the phasor diagram, I would like to see the characteristic in order to be understood. Now, شباب, this dotted line represents the torque speed for the main winding only. So the dotted line and the characteristic up till the synchronous speed, this characteristic now alone represent the main winding. However, when we insert auxiliary winding, as you can see, the auxiliary winding will create a component for torque in the beginning. And it will continue since the auxiliary winding is still exists in the circuit. So when it will be disconnected, it will be disconnected at a 75% of the synchronous speed. Why? Because the switch, the mechanical switch or the limit switch, will be disconnected at that point. So when we disconnect the auxiliary winding, the current or the characteristic will continue operation of the motor at the main winding characteristic. So this is now the shape of the capacitor start motor. So we can call this type of شباب sorry, this is not capacitor. This is split phase motor. So this is the first way now. Right. So we understood now in terms of the characteristic how this motor will work, because we have auxiliary and main winding in the starting, and it will continue up till 70% of the 75% of the synchronous speed. So it will start in this shape يا شباب. طبعا it's very important to recognize the torque speed characteristic and the phasor diagram for each motor. Okay, motor here I mean the motor as we said in the beginning يا شباب in the first class, each type of starting will give a name for the motor itself. يعني if we have this method in starting, we will call it as split phase motor. All are single phase, we know that. However, we will give a name for the single phase induction motor based on the starting technique. So the starting technique here is based on split phase, so we can call the motor a split phase motor. So for the split phase motor يا شباب, we should recognize the phasor diagram and the characteristic, the torque speed characteristic, and also to recognize the circuit here, the mechanism of the circuit itself.
Doctor?
تفضل.
The switch of the auxiliary winding, is it on rotating or on the stator part?
All of these parts are in stator. However, it's facing the rotor motion. So the rotor motion itself will affect this switch. Okay? Yes. Because of the high speed. So when you reach to a certain speed, which is 75% of synchronous, it will be affected and disconnect the motor. Right.
Okay.
Right. In terms of characteristics or phasor diagram now, شباب, let's see the performance of the motor. Here, I have some comments here that the auxiliary windings has a higher resistance to reactance ratio. Why? As you can see, this is now IM. IM has a higher L to R ratio, so inductance is higher than resistance. However, the auxiliary winding will have higher resistance to inductance. Why? Because we need to make a phase shift. And according to this phase shift, which we call it in the revision as theta A, okay, you can have a component for flux. So this is now the resultant current based on the difference between the two coils now. And this is enough to make spin a component for flux in the starting to operate them. The high RL ratio شباب is usually obtained by using a finer wire for the auxiliary winding. So you don't have now high cross section. The cross section here is small. This is permissible because the auxiliary winding is in the circuit only during the starting period, and the centrifugal switch will cut it out at about 70%, 75% of the synchronous speed. The question here, what will happen if the centrifugal switch fails to open? شباب. What will happen if this switch fails to open at 75% of the synchronous speed? شباب. What do you think?
It will continue working.
But if it is continue working in the circuit, we said that this winding has high value of resistance. So we expect
we won't
to have
get enough current.
The current is enough to operate the motor, because as you can see here, if we compare it in terms of phasor diagram, even the current is higher than the main current. So it will continue working in terms of current. However, we have another problem. This resistance is high, which means you will have, beside the efficiency also, you will have another problem. You know the copper losses will be high, this is right. However, this winding is not designed to operate for a long time. It's only designed to operate the motor for certain period in starting. So if you continue connecting this winding, it may be burned because of the value of losses here. And in this case, the winding may be damaged, may be burned due to the high temperature of I square R. Okay, شباب? So this is now one of the drawbacks of using this type of switch. If it is failed to open, so the motor after certain period will be burned. Now another question, what will happen if the centrifugal switch fails to close?
It will not rotate.
It will not rotate, so the motor will not start. This is right. So you have to recognize what will happen if you have a faulty centrifugal switch operation. If it is failed to open or fail to close. This is important. The typical torque speed characteristic of the طبعا شباب C/C, it means characteristics. Okay. So the typical torque speed characteristic of this motor is shown beside. This is our A characteristic. We discussed it already. This motor has low to moderate starting torque. So the starting torque here is not that high. So we don't prefer this type of motor if we have mixers, like what we discussed for universal motor, for instance, blenders or mixers. Okay. This is one of the drawbacks. Also, another drawback we just discussed is the mechanical switch using. You know, all of time, if you have electrical solution, this will be much better because you may have a lot of problems due to mechanical solutions. As we discussed, if it is failed to open or failed to close, it may cause problem. Right. So here we have a problem regarding starting torque. Okay. The starting torque can be increased by inserting a series resistance in the auxiliary winding. So if we inserted series resistance again, what will happen? Let's see in phasor diagram. If you insert more resistance in series with this winding here, so this means the current component angle will be very close to V. صح يا شباب? So this is going to make higher difference, and this higher difference will attain higher flux and higher torque. So if you increase the angle alpha, this is going to increase the value of starting torque. Is it clear يا شباب? Any question? So this is the first type. Second type, we call it capacitor start motors. We just discussed the effect of angle between main and auxiliary winding. Now, what's your opinion if we added capacitor here in series with the inductance instead of resistance? Now, if we added capacitor, the angle will be increased more. And this is going to increase our starting torque. Is it right? So if we use the capacitor start motor, and we call it start because the capacitor will be removed from the circuit after starting. We need it only in the start period. So, like previous characteristics, the starting or the auxiliary winding along with the capacitor will be exist until 75% of the speed, and the centrifugal switch will be disconnected at this instant. And the motor will continue working on the main winding characteristic. So this is another way, شباب, to start the induction motor. It's called capacitor start motors. The capacitor will be inserted in series with the auxiliary winding, and it will be disconnected at 75% of the synchronous speed. So this is going to give you higher starting torque. Okay. The torque speed characteristic is shown in side. This is a characteristic. The capacitor is an added cost. This is considered as a drawback here. By the way, this capacitor is very expensive. okay, because it works with high voltage. A typical capacitor, طبعا high voltage I mean relatively high compared to the single phase supply, okay. A typical capacitor value for 0.5 horsepower motor is around 300 microfarads. طبعا يا شباب يعني the volt may reach around يعني 400 volt for this type if we use 220 volt طبعا because of the يعني the problem of transient, the voltage here will be higher. So you have to select around 400 volt, and also the microfarad will be around 300 microfarad. So it's not cheap one. The cost is high for this type of capacitor. However, we have the advantage of high starting torque due to the phase shift between IM and IA in the start. So this is the second way, which is called capacitor start mode. Any question regarding this technique? Is it clear? So for now, Shabab, we have how many techniques? Automated techniques?
Two.
Two techniques. Split phase one and the capacitor start one. Type. Regarding the problem of centrifugal switch, another technique is used with capacitor run motors. Instead of using centrifugal switch, Shabab, we can use a capacitor in series with the auxiliary winding, and it will be here connected all of time. It will not be disconnected. But why we make that here, Shabab? We make that because of the problem of the mechanical switches, because it may damage or fail to open or fail to close like that. So it makes a lot of problems with machines. For that, capacitor run is preferred. So this technique is called the capacitor run, and in order to keep the coil here in the circuit all of time, this means you have to decrease a bit the value of resistance in order to work with the motor and continue operation without burning the coil itself. So the R2L ratio here has to be decreased in order to carry higher current. But in this way, Shabab, as you can see, the value of torque will be decreased again. Why? Because you already decreased the value of resistance here, which means the angle between IM and IA will not be that high compared to the start or compared to the capacitor start one. So this is a problem of starting here. The torque will not be that high. Okay.
دكتور
تفضل.
معلش مقاطعة بس الكويز متى هيبدأ؟
لا احنا we postpone the quiz to some day based on your recommendation last class.
Okay.
So Shabab, this is now the capacitor run motor. It will continue operation during the steady state. As you can see, we have only one characteristic, which means it can continue from starting to steady state. So adding this capacitor in the circuit, Shabab, will solve the problem, and you don't need to make any other mechanical solution. This is very good now. Another solution is capacitor start, capacitor run. What do you think, Shabab? Why we need this technique?
To increase the starting torque.
Exactly. So in order to increase starting torque again, we can add another capacitor, okay, with the centrifugal switch. However, we return it back again to the problem of centrifugal switch. However, it's already a technique used in industry as well. So the characteristic here will be like that. It will starting here in this characteristic, which is considered as the characteristic of both of capacitors along with the two inductors. Okay, so this is now the characteristic for all of the circuit connected together while CS is closed. After that, when CS is open, you will return back to the characteristic of طبعا characteristic it's moving like that يا شباب تمام for the characteristic of the capacitor run motor. Okay, so this is the fourth technique here. So up till now we have 4 different techniques. The fifth one and last one is called shaded pole. Here we don't need any capacitors. and the starting torque here is not required to be high because this technique is mainly used for very small power, very small loads, and fan load type. Fan load, which means torque starting for load equals 0, where torque is proportional to omega squared. So the main application of this type of shabab, where torque is proportional to omega squared. You don't need to have high starting torque. You just need to push the motor to a, I mean the flux need to push the motor to start, not by hand. Like what is the basic of this technique? Simply, if we made a slot within the stator ball like that, and added just a ring or coil, small coil like that, what will happen here? You will have a component for flux. Why you have a component for flux? Simply, when a flux is moving in the shaded ball, assume that this is N and that is S, so you will have moving flux here. The moving flux will cut this ring because it's wire or copper. So you will have an eddy current here or current within this ring, and the current will make its own flux. The summation of the flux due to the shaded ball in the beginning will act as auxiliary wire. So it will make a small component of flux, okay, shabab, and it will start the motor. Like that, as you can see, you have small starting, but the motor can start and work without any mechanical solution. You can find this type of motors, shabab, in the fridge fans. You know, for most of fridge, shabab, we have the upper part for freezer and lower part for fridge. And the idea of operation for the fridge, it exhausting the cold air from freezer to go down in the fridge part. So this exhaust needs fan. Simply this fan is made or work based on a shaded ball motor. So this is the application for that type of motor. It's a very small one. Okay, and you can find it in your fridge at home. It's a very small motor. Okay, and even the stator is not covered. It's open, and in order to evacuate any heat from the motor itself, and it will it will be cooled by means of the fridge itself. ماشي شباب. So this is the last solution, and the power for such applications, شباب, as you can see, it's about 1/20 horsepower. It's a very small fractional power, شباب. Okay. So this is now the last technique used for starting the motors. Now we could understand the different techniques of starting. Inshallah, next class, shabab, we will start analyzing the performance of the motor and make modeling and equivalent circuit for the motor. طبعا in case of steady state. Now we don't care about the transient. We will care only about steady state of the motor, which mainly will describe the motor while we connecting the main winding. So we will stop at that point, shabab, and we will continue inshallah next class. Any questions, shabab? Any question? نشوفكم ان شاء الله كلاس القادم.
دكتور لو سمحت.
تفضل.
بس بخصوص اكتيفيتي 6 دكتور، انا امس راسلتك